Next up, we want to draw the function of fx. So when we draw functions, we first want to draw in the axes. So I will draw in the y-axis and the x-axis, indicating it with a y and an x, also showing arrows and also showing the origin. Then to draw the hyperbolic function, the first thing that I would draw in is the asymptotes. So we know that the horizontal asymptote is y is equals to 5, and the vertical asymptote is x equals to -1. Notice that when I draw in the asymptotes, I indicate the equations of the asymptotes on my graph. Next up, we have the x and y-intercepts. We know that the x-intercept is at -2/5, and the y-intercept is at +2. So I can draw in my first half of the hyperbolic function. Notice that this curve does not cut through the asymptotes, so it can never cross the asymptotes, and I'm indicating the x and the y-intercepts. And finally, I draw in the second half of the hyperbolic function. Notice that this curve also does not cut through the horizontal and vertical asymptotes, and I indicate one coordinate on this curve. So what I simply did is I substituted -2 in the place of x, and I found a y value to show that this point exists on the function. And then lastly, I name the function f. Next, we want to discuss the domain and range of this function. So the domain is all the x values at which the graph would exist, and the range is all the y values for which the graph would exist. So in order to find the domain, I use a ruler to simulate -infinity on x, and I ask myself, does the graph exist at -infinity of x? So this arrow indicates that the graph will continue forever in a negative direction. So yes, the graph will exist, and I follow my ruler, and I can see for all values of x, the graph does exist. And then I'd see at the asymptote, the graph does not exist, but after the asymptote, for all the values of x, the graph does exist, and it will do so up until x is equals to +infinity. So the domain is x is every real number except for -1. Similarly, I can find the range. So I go to -infinity on the y-axis, and I see whether or not the graph will exist at -infinity, and it will. And I move up for all values of y, and I can see that the graph will exist up until I reach the horizontal asymptote of y is equals to 5. So at this point, the graph will not exist because the hyperbola will never cut these values or never exist at y is equals to 5. But afterwards, I can see that if I draw horizontal lines from the y-axis, that the graph will exist, and it will do so up until y is equal to +infinity. So the range is y is every real number except for y is equals to 5. Next up, we want to determine the axes of symmetry. Now the hyperbolic function have two axes of symmetry. So the first axis of symmetry is where the gradient is equal to 1. Now what an axis of symmetry is a line that represents the exact middle or mirror between these two parts of the graph. So if I fold the part on the left over this axis of symmetry, it would fit exactly on the part on the right hand side. So it will mirror it exactly. Also notice that this axis of symmetry runs through the point of intersection of the asymptotes, and that the gradient of the axis of symmetry is equal to positive 1. So this is a axis of symmetry with a positive gradient, which will reflect the two parts on each other. And our second axis of symmetry has a negative gradient. Now what this axis of symmetry represents is folding each curve on itself. So if I fold the graph on this line, this part of the curve would fold exactly on the part on the left. And the same for this second curve. So this left side of the curve would be fold exactly on the right side of the curve if I fold it along this line. And the gradient for this axis of symmetry is equals to -1. And notice it also runs through the point of intersection between the asymptotes. So now we can find this coordinate, which is x equals to -1 and y equals to 5. And I can use those values in the straight line equation in order to solve the equations of the axis of symmetry. So the values of x1 and y1 would be -1 and 5. So I replace y1 with -5 and x1 with -1. And if I simplify, I see that the one equation of the axis of symmetry is y is equals to x plus 6. And for the second axis of symmetry with a negative gradient, I would simply substitute in those same values for x1 and y1. And if I simplify, I see that this equation is -x plus 4. Next up, we want to describe the transformation from f to g. So here we have gx is equals to 3 over x plus 1 plus 5. And the simplest way to describe a transformation is to write both equations next to one another. And what I can see is that the only value that changed is the a value. The q value and the p value is still the same. And remember, the a value shows the quadrants in which the graph exists. So we only shifted the quadrants from quadrant 2 and 4 to quadrant 1 and 3. Now how we describe this transformation is I can say that the original graph has been reflected over the horizontal asymptote, or it has been reflected over the vertical asymptote. So if I reflect the original graph in its horizontal or vertical asymptote, it will produce these quadrants. So my answer could be reflect f in the vertical asymptote of x equals to -1, or I could say reflect f in the horizontal asymptote of y is equals to 5. And then our final question is determine the equation of hx if h is f moved up by 3 units, left by 2 units, and reflected in the y-axis. Now the easiest way to determine the equation of h is to apply these transformations one at a time. So first off, we want to move the function of f up by 3 units. Notice I replaced fx with a y. So to move up by 3 units, I need to add 3. So the new equation would be negative 3 over x plus 1 plus 8. Now in order to move the graph left by 2 units, it means that x plus 1 in the denominator needs to move left by 3 units. So the p-value now would be plus 3. So y would be equals to negative 3 over x plus 3 plus 8. And now I've moved the graph left by 2 units. And then lastly, I need to reflect the graph in the y-axis. So if I take a point and I reflect it in the y-axis, the y values would remain the same, but the x values would change from positive to negative or negative to positive. But notice when we reflect in the y-axis, only the x value changes sign. So therefore, I would have y is equals to negative 3 over negative x plus 3 plus 8. And that is our equation of hx. Y is equals to negative 3 over negative x plus 3 plus 8.